On this video, we're going to determine whether each relation represents a function, and for each function, state the domain and range. Now, the second part where it says for each function, state the domain and range, that doesn't mean that relations don't have domain and range. You can always find the domain and range of any relation. Okay? So now, what makes a relation a function? Well, let's look at these two examples right here. Here you have Pearson and birthday. Person and birthday. And then here you have father and daughter. Okay? In order to be a function, the correspondence between the input can only have one output. Now, if the opposite happens, for example, father, here Bob has both daughters, Beth and Diane, this relation violates to be a function because the input of Bob has two different outputs, Beth and Diane. On this hand, this is a function because Elvis and Colleen only have one input, one output, okay? So it doesn't matter how many inputs do you have for one output, it just have to have one output, okay? So the first one is a function, so this relation, function. The second one is not a function. Okay, now for the domain and range. The domain and range are sets, okay? Functions and relations are sets, but they're a different kind of set. They're ordered pairs. But for the domain and range, you don't have an ordered pair, okay? So for the first one, you have that the domain since we only have individual elements, we can write them inside a bracy bracket. So the domain are the inputs. So Elvis, Colleen, Calais, and Maritza. Okay. Now, very important. Each element is separated by commas. Okay. It doesn't matter the order of the domain in these sets. Okay. Now the range is going to be, it's also a set, but this time is the outputs. So January 8th, March 15, and September 17. Now, for this relation that is not a function, you can also find the domain and range. Okay, here the domain are Bob, John, and Chuck, and the range is Beth, Diane, Linda, and Marcia. Now, if you're giving numbers, for example, here, these are ordered pairs. Okay, and by the name you can notice that order does matter for ordered pairs. So is this set a function? Well, what corresponds to be a function? For every value in the domain, you only have one output. So look at these two values, -2. -2 here has 4, but it also has 6. Therefore, this set is not a function. Okay. Now, what would it need to be? What would I need to do to make it a function? Well, I'll have to replace 4 by either 6 or replace 6 by either 4. Why? Right? Because they have to be the same output. Okay? So now, even though this relation is not a function, you can still find the domain. So let's do that. Domain here are the inputs. So it's going to be -2. Now, if the inputs repeat, you only write it once. So -2, 0, and 3. And then the range are the outputs. 4, 6, 3, and 7. Notice that it doesn't have to be in order, okay? It's not a requirement, but for order pairs, it does. And by order pair, I mean these parentheses here, okay? Now, you also know order pairs as coordinates or points in analytical geometry. Well, that's all for today. If you have any questions, leave it in the comments below or ask me in class.